now let me show you what a cube actually looks like. This is an example of a cube. If you notice, at each surface you see is a square. It's made up of 6 of these square surfaces. We have a top, a bottom, 2 sides, you might say a front and a back. It's really, you could envision stacking a bunch of squares up. If you imagine your bottom being a square and then you're stacking squares up so high. So this is actually a cube. Each surface is a square. Now, if we wanted to find the volume of this cube, what we want to do is to see how much space it covers. Or if it was hollow, we want to see how much it takes to fill it up. So let's look at a cube that's hollow. Here's an example of a hollow cube. Doesn't have a top to it, but you can imagine the top being there. And actually inside of this cube, I have little square centimeters. Now, it's going to be hard for you to see these little centimeters, but a centimeter is about the width of an aspirin, like a Bayer aspirin. And so what I have here is a little cube that's made up of 6 square surfaces, and each of those little squares is a centimeter by a centimeter. So if I want to see how many of these little cubes fit inside of this cube, I would just have to start filling it up with these little cubic centimeters. And when I filled it up, it ends up that I would have 1,000 of those cubic centimeters in here, because I can, if I go all the way across here, I can fit 10 across this way, and I can fit 10 across the front. So the bottom layer would have 100 of those little squares, and then it ends up that if I actually had enough, I could stack them up 10 centimeters high. So my height would be also 10. So if I had a length of 10, a width of 10, and a height of 10, it would end up that it would give me 1,000 of those little teeny centimeter cubes inside of this. So when we're finding the volume of a cube, what we're doing is seeing how many little cubic units, whatever your unit is that you're measuring with, how many little cubic units will fit inside of your figure. So let's actually look at a cube and try to find its volume. Before we take a specific cube, I want us to talk about the formula for volume. To find the volume of a cube, what you have to do is know the cube's length. This we could consider its length. You have to know its width, and you have to know its height. And you multiply those 3 dimensions together. Length times width would be like the area of the square on the bottom, and then those squares are stacked up so high. So if you do length times width times height, you'd have the volume. Now, it just so happens that in a cube, since the length, the width, and the height are parts of squares, and all the squares are going to be the same, they're all going to be the same size. So instead of saying length times width times height, what would be better to do probably would be to say side times side times side. What I'm going to do is let each one of these little edges here call them a side. So instead of putting length there, I'm going to put an S for the side, and here an S for the, we're going to let this edge be S. So the length, the width, and the height are going to all be S. So the way you would find the volume is to say S times S times S, or S to the 3rd power, or S cubed. The formula for the volume of a cube is just S cubed. So if you know how long an edge is, if the edge is S, then all you have to do is multiply S times S times S, or S cubed, and you can tell how many little cubic units you'll have inside of your cube. So let's find the volume of a cube. This particular cube is supposed to have an edge S equals to 2.5 feet. So And I want to use the formula V equals to S cubed. So what this means for my particular cube, my length, my width, and my height will all be 2.5 feet. So in other words, if this were my cube, my length would be 2.5, my width would be 2.5, and my height here, and I'm going to label my height over here, would also be 2.5 feet. So all three of those dimensions, since the cube's surfaces are all squares, they'd all be the same. So if I fill into that formula, I would just have 2.5 cubed. Now in order to raise 2.5 to the third power, I need to multiply 2.5 by itself 3 times. But I need to make it an improper fraction first. So when I do that, I'm going to get 5 halves. So I'm going to have 5 halves times 5 halves times 5 halves. So when I multiply that together, I'll end up with 125 eighths. And I'd like to change that back to a mixed number. So I divide 8 into 125. Go one time. 8 will go into 45. 5 times 8 is 40. So I'll end up with 15 and 5/8. It goes 15 times with 5 left over, so it's 15 and 5/8. And my unit of measurement would be cubic feet. See, up here at the beginning, I was working with 2.5 feet. So I've got to keep my feet. And since I'm seeing how many little cubes will fit inside of this little cube, I'm stacking up little cubes on the inside. My volume will be in terms of cubic units. So I'd want to write the word cubic feet, or I might say feet with a little 3 up here beside it. That also means cubic feet. The other three-dimensional solid that we want to talk about is a rectangular solid. In a rectangular solid, your 6 surfaces, instead of being squares, are rectangles. And your 3 dimensions, your length, width, and height, are not necessarily equal. Here's a picture of a rectangular solid. Notice that you see that you have rectangles as your 6 surfaces. You might possibly have 2 of your surfaces might be squares, but at least some of your surfaces would have to be rectangles. So your length, width, and your height would not all be the same. And the way you find the volume of a rectangular solid, or a box, we often call a box a rectangular solid, is to multiply the length times the width and times the height, just like you do with a cube. But in this case, the length, width, and the height might be different. So you don't put S times S times S. You leave it length times width times height. Some examples of rectangular solids would be any kind of box, a freezer that's rectangular shaped, a rectangular shaped swimming pool could be considered a rectangular solid. And you might, when you're finding the volume of a swimming pool, you'd be trying to see how much water it would take to fill it up. A toy box could be a rectangular solid. There are a lot of storage bins that are rectangular solids. A car's gas tank might be an example of a rectangular solid.